Hello folks, this is 2022 May-June paper 2-2 and the question number is 6. This question is also concerned with the chapter current electricity. As you can see from the figure, it says a network of three resistors of resistances R1, R2, R3 is shown in figure 6.1. The individual potential differences across the resistors are V1, V2 and V3. The current in the combination of resistors is I. So if it is I here, it should also be I here, I everywhere. And the total potential difference across the combination is V. Show that the combined resistance R of the network is given by R equal to R1 plus R plus R. So we are given that this V is the combined potential. So V should be equal to V1 plus V2 plus V3. Now since we have current equal to I, it should be I into the combined resistance R equal to I R1 plus I R2 plus I R3. So if I cancel this I, it will give us R equal to R1 plus R2 plus R3. Not a difficult job. Now in the second number, B, a battery of electromotive force 8 volt and negligible internal resistance is connected to a thermistor. This is the thermistor, a switch X and two resistors as shown in figure 6.2. Resistor R1 has a resistance 6.0 kilo ohm and resistor R2 has got 4.0 kilo ohm like this. So all are given quantities only. Now switch X is open, so we can see here switch X is open here, calculate the potential difference across R1. So we have to calculate the PD across R1. So if this is open, the circuit is just like this. This part is useless. So if the circuit is like this, we can find the voltage here by means of the voltage divider formula. So it should be, let me fold this paper. So now it should be somewhat like this. So our V1 should be equal to R1 by R1 plus R2 into E. So that's equal to R1 is 6, again 6 plus this R2 is 4 into this whole EMF is 8. So it should be equal to 6 by 10 into 8, so 68, 48 by 10 equal to 4.8 volt. So it should be equal to 4.8 volt. Now switch S is closed. This is now closed. The resistance of the thermistor is this RL is equal to 12.0 kilo ohm. We have to find the current in the battery. So we have to find this current I. So first let us find this circuit here. So let us say this is A and this is B. So I have got this RAB is equal to parallel of 4 and 12. So it is 4 into 12 by 4 plus 12 equal to 48 by 16 equal to 3 kilo ohm. So RAB is equal to 3 kilo ohm. This gives the value of current is equal to total EMF by total resistance. So it should be equal to E is 8.0 by RT is R1 plus RAB, and that's equal to 8.0 by R1 is 6.0 plus this RAB is equal to 3.0 equal to 8.0 by 9.0. And since we have got this kilo here, it's equal to into 10 to the power 3, that will be equal to 8.89 into 10 to the power minus 3 amperes. So this thing is somewhat familiar to me. It is 8 by 9 equal to 8.9. I often used to mug it up. So it's like this. So this is 8.89. Sorry, it is minus 4. Sorry, it is minus 4 here. So it is 8.89 into 10 to the power minus 4 amperes. Now the switch X in current remains closed. Switch X in current remains closed. It says the temperature of the thermistor decreases. So this temperature decreases. It says by reference to the current in the battery, state and explain the effect, if any, of this decrease in temperature on the power produced by the battery. So we have to find its effect on the power by the battery. So what we are given here is temperature decreases. If so, then R of LDR will increase. This will increase. If this increase, RAB increases. And if so, then R total of the circuit also increases. So this will cause decrease in the current. Overall current I decreases. So now, since the power produced by the source power is equal to E into I, this also should decrease. So as the temperature decreases, the power produced by the source also will decrease. So that's the answer to this question.